Hey guys, a very warm welcome to the Kubernetes Chaos Engineering Meetup under the Cloud Native Foundation hosted by LitmusChaos. We are elated to have you all here on a Saturday morning. Namaste everyone. It's a Ganesh Puja day, so I wish you a very happy Ganesh Puja to all of those who are celebrating. Today on agenda, we'll have an introduction to Cloud Native Chaos Engineering for all the new folks out here who do not have an idea about what is Cloud Native Chaos. Well, I would like to begin with something before moving on with the agenda. Recently, I just attended the KubeCon and I heard that the new paradigm will have testing and resiliency as the most important factor. Now, what chaos engineering helps you with, or what chaos engineering exactly does, is help you understand how resilient your infrastructure is. And what I believe is that moving on with chaos, I got to know that a lot of people do not have an idea about chaos itself. And I believe that a lot of people present here might also not know what chaos engineering or what Kubernetes exactly is, as Gagpreet mentioned. But our agenda is mainly to help spread the value and impart the value of chaos engineering. And also I'll make everyone realize that coming up with the new paradigm in the cloud native world, chaos is going to be really important, as resiliency is what matters, and the chaos first principle as we follow is what defines us. Why to have chaos later on? Why not at first? So as we have on agenda today, we first introduce you what is cloud native chaos engineering and what exactly Litmus is. Followed up by we move into the Octato world, where we talk about the latest development where we deploy chaos on the Octato cloud, which will be explained by Karthik. And in the end, we'll have a probing on chaos experiments flow with Litmus probes, which will be explained by Shubham. We can also have a question answer session or a one-on-one session as you want. And after each session, we can start off with what exactly is in your mind or your views on this. So before we start off with the agenda, I would just like to introduce you to the chaos bird. Can you see my screen?
Yeah.
One second, probably. Yeah, this is the chaos bird, the new mascot or the new logo to the cloud native world. We thought about a lot when we were designing this, and this basically represents an SRE or a Kubernetes developer wearing the perfect attire the one should have while experimenting with a lab coat, a lab classes. And this is going to be the new mascot for the upcoming meetups for Litmus overall. You can check that out on our website, litmuschaos.io. And one thing I would like to invite you all to do is join us on Slack, hashtag Litmus channel or Kubernetes Slack. I'll be forwarding the link while the meetup goes on, so that we can stay connected, we can learn, we can have all our queries, everything cleared out, and we can learn more in this Kubernetes chaos engineering journey with Litmus. So I would like to give the floor to Karthik, who will start by introducing chaos engineering to you. Thanks.
All right. Thanks, Prithvi. Happy to see a lot of folks today. As you mentioned, I see Randir. We've been having a nice conversation on Slack. Welcome, Randir, and a lot of others. Happy to have you back, Vishwanath and Krish. Let me just share my screen. I have a few slides to talk about cloud native chaos engineering, and we'll go on to the Octato discussion afterwards. So Prithvi, I think you'll have to grant me access to share the screen.
Yeah, Karthik.
Okay, I think you've given that. Okay, let me go to the slides. Okay, a lot of folks here are familiar with chaos engineering already. There are some new joinees as well. So I'll just talk about chaos a little bit, and then I'll come back to the first few slides that I just skipped now, talking about Litmus project. So I think like Gagandeep mentioned, a lot of people are starting to adopt Kubernetes. They're they're either looking at Kubernetes, they're evaluating it as the platform of choice, deployment and development platform of choice, or they might have already made the transition. A lot of people have. You can see that the chasm is actually being reduced. A lot of people are crossing it and moving on to the other side where they are becoming adopters of Kubernetes. One of the common questions as people move into Kubernetes is about how stable their applications are when they get deployed as microservices. A lot of times during this journey into Kubernetes, they might have re-architected their applications. They might have made a lot of changes to the way they have structured or architected their apps. They might have created microservices out of what might have previously been legacy applications. So there's a fair bit of apprehension around how it is going to behave on the cluster. And Kubernetes itself is a complex system, right? It is composed itself of several services, and there is a fair bit of learning curve in terms of installing it and maintaining it, though it is being made simpler with all the managed services and all the other tooling that's there. But still, people want to know how their applications are going to behave. And it's not something that is done at one time. Of course, you need to check how the resiliency is during onboarding, but you also need to maintain those resiliency levels as your apps continue to live and scale on Kubernetes. So one of the ways to do it is to define what your resilience parameters are, right? And resilience is a term that has a very broad connotation. One way of defining it is to say that it is your system's ability to stay afloat when a fault happens. In other ways, in terms of microservices, it is basically to say your app is alive despite failure of system components. System components can mean a lot of things. It could be your the stateful pieces of your application. It could be in the Kubernetes services themselves, or it could be the physical infrastructure that is supporting your Kubernetes, your disks, your nodes, the network, all these things. So there is a lot of aspects to maintain, a lot of areas which you need to keep your eye on in order to stay resilient. When you are making your services as microservices, when you're breaking your monolith into several microservices, you can also see that the surface area for faults or failures increases. There are a lot of points where it can fail. So for example, let us say you've put your application into different Kubernetes pods, you've got different replicas. Your pod might get evicted from your node, either because of some policies that you've set on your node. It could be because of certain resource requests or limit that you might have set. Because it is exceeding, it might have got evicted, or the node might be taken for maintenance, or there might be some node failures, or there can be any reason your pod might get evicted from your node and then it has to be rescheduled. And during this process, your service has to be healthy. So if that has to happen, then you need to follow certain best practices. Whether you're following those best practices consciously, or you might have forgotten to do that sometimes, you need to have some mechanisms to highlight that for you as you go, as you scale, right? And there are also some service level parameters. You might have a certain acceptable performance limit or failure toleration limit on your services, which you might have to monitor, which you might want to check. And instead of this happening to you, this hitting you sometime when you're not prepared for it and it is least expected, and then reacting to it, you can actually start testing out these things much earlier in an environment that mimics your production, the real environment where your apps are going to be deployed, and thereby find out how the application behaves and be prepared with the response, be prepared with all the mitigation right in your application or your deployment practices, or even in the way you respond to it. So chaos engineering helps you to do that. So when we say cloud native environment, you can see this picture here. It's a box in which there are just too many cards. This is the cloud native landscape from the CNCF website. The landscape is structured or divided on the basis of certain categories. They are not very visible in this slide, but there are things like CI/CD tools, there are monitoring tools, then there is storage, there is runtime, there are so many things. right? Each component or some representative from this particular chart or landscape is what you might be using in your environment, and they come with their own resilience challenges, right? And you need something like chaos engineering to help you to validate whether things are all happening as expected. So chaos engineering is a term that was coined by Netflix, and it is an advanced form of failure testing, right? So here things are experimental. People do not run tests, they run experiments, though there's a very thin line separating them. In case of experiments, you are defining what is called hypothesis. You have something called as known behavior, that is, you know, this is what is going to happen. Then there are known unknowns. You know a behavior of your surveys under these conditions, but you don't know what happens when you scale that, for example, right? Or what happens over a period of time, over some duration. So there is a known unknown. Then there are unknown unknowns. What happens when your load balancer suddenly goes kaput, for example, right? So chaos is basically helping you to hypothesize and validate your hypothesis. And that's how it's different from tests. Having said that, people are actually trying to build chaos engineering into their CI pipelines as well. Typically, because you have CI/CD pipelines today, your application development is very fast. That's what this slide is trying to indicate. You have a very well-oiled CI/CD machinery. You are deploying applications, you're building them, and then you're immediately deploying them, and then you're testing it out, and then you're rolling it out into production. So not only do you have a lot of components where failures can happen, but the amount of time, the turnaround time for you to develop and get it into production is also sort of reducing. There is demand for faster changes to be rolled out. And it's necessary that you have some kind of chaos engineering automated and inbuilt in your CI/CD as well. So that's something we will talk about maybe as a separate topic one day, but that's what is happening. This slide is basically trying to talk about what all components are there in your Kubernetes cluster. Your platform service and your Kubernetes services. When I say platform service, it means infrastructure. You could be on VMware, or you could be on some kind of a bare metal shop that you might have set up in your labs. You could be on the cloud, GCP, AWS. Then you have Kubernetes services on top of it. Then you have all the components that I mentioned from your CNCF landscape, or your cloud native services, monitoring services, DNS, service meshes, storage, container native storage like OpenEBS, etc. Then you have the stateful applications, things you have brought from your legacy world into Kubernetes. You might have operators monitoring or managing your stateful applications like Mongo, Kafka, Percona, Postgres. Then your business application, which is making use of everything below, right? Failures can happen anywhere, which is why chaos is really important. I'm trying to use these slides just as pointers to speak my mind, right? I'm not following this in complete sequence. And since we are sort of a 1 hour meetup today, I'm taking the liberty to just put out things in a summarized form and move ahead. So resilience is important. Chaos is a way to test resilience. And it's something that you need to do continuously. So there's a very interesting page, a single page website called Principles of Chaos. You can take a look at that. And that talks about chaos. What are the principles of chaos? What is there in chaos engineering? It is identifying steady state conditions. So you need to define hypothesis. This is how your system has to behave. Then introducing a fault, introducing it in a continuous manner, being able to automate fault injection. Right, and being able to check what is the experiment's result, what is the happening, what is the set of services that are going to be looked at after you've induced a fault, and whether they are in the desired condition. And if that is the case, then probably taking that to production. That's what principle of chaos. Principles of chaos say that you should be testing on production, because very often your CI/CD or your development environment is very different from how your production turns out. Right, you may mimic it to a certain extent in your staging, but the eventual goal, as the chaos frameworks reach maturity, as your applications reach a certain level of maturity, and as your response teams, as your SRE practices reach a certain level of maturity, you start doing chaos in production. That's the ultimate goal. So one of the things that's about chaos engineering. what is cloud native chaos? We talked about cloud native components in your application stack, your Kubernetes infra. But what is meant by cloud native chaos? So you're used to dealing with all your Kubernetes services in a declarative manner. That's the huge revolution that has happened over the last few years, where everything is inside of a YAML. You have something called custom resources provided by Kubernetes, which is able to help you extend the Kubernetes API. So you can create a resource in Kubernetes which understands your application, your business logic, right? That is the beauty of the custom resources. And people want to use the same way to do chaos. They want chaos to be natively understood by Kubernetes. They don't want to enforce it, right? And you want to, as a SRE or as a developer, you want to talk chaos in terms of YAML. You want to use the YAML language for defining your or expressing your chaos intent, right? And you also want to automate it. So this is what is meant by cloud native chaos. So what we are doing is we are allowing you to retain the same UX or user experience when dealing with Kubernetes. Just like you define a deployment YAML or a stateful set YAML or anything, you could also define chaos YAML. You will have custom resources for chaos understood by what is a chaos operator, which is provided by cloud native tools like Litmus. And you are able to, by tuning certain policies inside of your YAML, apply certain chaos to certain applications for a certain period of time. This is how you declaratively manage chaos. So that is what we are terming as cloud native way of doing chaos engineering. Today, the word cloud native is very much Kubernetes native. So it's almost like a synonyms. You'll have to read it like that. When you say cloud native, it mostly has something to do with Kubernetes. Okay, so this is something that we already discussed. The Litmus CRs, the one that I just spoke about, are the chaos engine CR, the chaos experiment CR, and the chaos result CR. So there are three separate custom resources. You might ask why. Does it make UX difficult? No, not at all. The chaos experiment is something that you pull. It's an off-the-shelf manifest that you pull from what we call a chaos hub, which I'll show shortly. And the chaos result is runtime generated. It talks about, the chaos experiment talks about what you need to do as part of a particular experiment. Let's say you're doing pod delete. For how long you want to do deletes and what is the image that's going to run on your cluster to effect these pod deletes. You want to do a forced delete, you want to do a graceful delete, or you want to do network delays, what kind of network chaos parameters you want to pass to it. All that's defined in what we call experiment CR. And if you want to find out what's happened as part of the experiment run, those details are present in the chaos result, right? Any information you want to pass as part of your result, anything you want to observe, you can push it into chaos result. Chaos engine is the user-facing CR. This is what you'll be mostly dealing with. This is about connecting a particular instance of your application. Maybe you're running a Mongo stateful set in a namespace called Mongo. You want to do a container kill experiment. You want to force kill, perform sick kills of some of the Mongo containers. You're going to connect a chaos experiment for container kills with a Mongo instance and also define how to run it. You want to run it with monitoring, without monitoring. What is the kind of blast radius you want? Whether you want to target a single Mongo pod, you want to target multiple pods, all that can be defined in the engine. So these are the custom resources, and these custom resources are watched by and managed by what we call as the chaos controller or the chaos operator, right? So this is how cloud native chaos works. And there are other several abstractions on top of cloud native chaos YAMLs, these chaos resources. We're also integrating with other tools in the community, in the cloud native community like Argo. So you can run Argo workflows, which we call chaos workflows. You can weave together several experiments if you want to execute them in a certain order. Sometimes you might want to do degraded chaos or multi-component failures. You might want to kill more than one application at the same time. So you could weave together multiple chaos engines to do that in an Argo workflow. And then you can also, as a side benefit of doing this way, the cloud native way, also do it with GitOps. What we call by GitOps is you have your infrastructure intent or your application intent stored in the Git repositories, and there are GitOps managers or deployment managers that are going to ensure that what you have in your source, your Git repo is what you have on your cluster. And because you made chaos into a YAML, you are defining it by YAML, you could also put it in your Git repo, and you could get your standard deployment managers, GitOps managers like Flux CD or Argo CD to go make changes on your cluster whenever there are changes to those resource manifests, chaos manifests on your cluster. So there are a lot of policies you can build around this. And you can achieve GitOps, which is one of the standards that's developing, that's emerging in the cloud native world. A lot of organizations which are accepting or embracing cloud native way of doing things are by default turning to GitOps, and cloud native chaos is well integrated to the GitOps practice. That's what we're talking about here. And the subsequent slides are basically describing the experiments, so I'll probably skip them. I think I have introduced cloud native chaos to you all. Now let's talk about Litmus a little bit. So Litmus is a project which is, it's an open source project, which is now part of the CNCF sandbox. And it is giving you all the, it's a complete framework, as in it gives you not only an orchestration framework to do chaos, means you can set up the chaos engine and the chaos experiment to define chaos intent and do it, but also gives you a ready list of chaos experiments you can pick and start using today if you're starting your chaos journey. The hub is some kind of a marketplace for chaos. So you have different categories of experiments here, and you can pick any experiment that you want from here and get started. There is the Litmus docs, which is talking about how you can get started with these experiments. Started the day-to-day with, on Twitter, I just saw somebody who was developing their app for a couple of years, first time subjected it to chaos and saw a lot of things breaking, and so we were pleasantly surprised. And if you are in that kind of a mode where you've not really tested your applications for failure conditions on Kubernetes, please feel free to do that. You can pick experiments off the hub. So Litmus is a project into which a lot of organizations are starting to contribute. So Maya Data is the primary contributor, and he started the project, and Intuit, Amazon, RingCentral, Dino Systems, the container solutions, and a lot of other folks, Microsoft, are contributing to this project. And the momentum is building in terms of capabilities within the solution. So we're trying to add experiment probes, trying to add more details, more information into chaos results, adding more new experiments, etc. So feel free to be a part of this journey. You could give us a star on the GitHub if you like us. You could take a look at the website. The docs are fairly exhaustive, so you can get started. And we've just been tracking some of the usage metrics for Litmus, and we're happy to know that the rate of utilization of the experiments and the number of operational installations are exponentially growing, which is sort of always a good sign for the community. And we look forward to your feedback when you try it. So that's about Litmus project and cloud native chaos. I can take some questions before I go to the next demo. All right. Are there any questions that I can take? All right. You could always join our Slack channel. It's in slack.litmuschaos.io. It's on the Kubernetes workspace. You can always join and ask the questions there. I'll do a very quick demo of the Octeto integration that's next on our agenda. Before that, let me talk about what Octeto is, right? So a lot of people who are using Kubernetes and who are developing applications on Kubernetes, right, might be aware of this problem. Typically, how do you develop it? You have a Git repo where your source code is. So you pull that code, right? You make changes to it. You go and modify your Python or Golang or Node JS code, your app, eventual Kubernetes app. And then after that, you're going to build your Docker image, right? And then you're going to push it to your local cluster, maybe Minikube, MicroKTS kind, for example, and test out its behavior. Then if you see that something is not right, then you go back, you make your changes to your application again you build your image, and then you test it, redeploy it, test it on your cluster. At some point when you feel comfortable, you're going to push your code to Git, your source, right? And then it goes through the CI/CD cycle and all that. So this period before you push it into your Git and before it goes into CI/CD and all that, what is called as a dev test, right? As a developer, you are testing your code on the fly. We popularly call it dev test. So this is also called as the inner loop of development, right? This is where your actual CI/CD machinery is not involved yet. You're doing things by yourself. It can get sometimes very irritating, for example, or it could be time consuming for you to repeatedly build your image, push it, redeploy it, test it, and all that. And sometimes you might not have the right, you might not be testing. Sometimes you can argue, I can just pass my kubeconfig flag or environment variable, and I can test from a cluster by just doing, let's say, a Go run or a Python run of my code. I need not build images, but a lot of times, many of your applications need in-cluster dependencies. You might be running your app with a certain security context. You might be using volumes, persistent volumes, or you might be using host path volumes, for example. You might be using MTDARs. You might be having shared, you might be using a Unix socket to share data. You might have multiple container sidecars, usually using the same storage. Or you might have to observe how things work over an ingress endpoint. You have all these things also to look for as part of your app development, and you can get that when you run on the cluster. Very difficult to sort of run your binary with the kubeconfig and be done with it. So you do go through this stage of dev test running on the cluster at some point, and it can get sometimes time consuming. Octito is a project which is solving exactly that. Take a look at this when you have time. So what they do is they provide a development environment on your cluster. That is, they can help you to create a development environment with all the bells and whistles and all the source code already loaded into it, but that actually runs as a deployment on the cluster. And using a sync mechanism, they are going to allow you to test changes you made in your workspace, right, on the cluster. So I would go and open my VS Code and make changes on the source code. That's automatically going to reflect, right, as a binary or as a .go file, for example, on your cluster, the pod running on your cluster. And then you could just do a go run there and see how it is behaving. So you're already inside of the cluster in a pod, which is already built with the right security context, the service account, and the volumes, and everything is already built in. You have that environment ready for you, but you also have the ability to test there directly instead of you having to push your Docker image every time you build and push a Docker image every time you're making changes. I'll demo this in a little bit. But why we are talking about Octito today is in the context of engineering. We said during our discussion that chaos has come to CI/CD. The paradigm is shifting left, right? There's a shift left there. People are testing chaos engineering in CI/CD pipelines and even during dev test. So you can actually subject your application to failures, different kind of failures, while you're developing and testing it. So Octito is a platform which is easing development, and they felt it's really useful to integrate with Litmus to help give their developers a better experience and give them a taste of how resilient their apps are even before they push it into their source repositories, right? So because of that, now they have actually gone ahead and made Litmus one of the deployable options within Octito Cloud. So Octito is an open source project. The Octito CLI is the one which helps you bring up that environment, development environment I spoke about. But they also have a cloud solution where, as developers, you get free namespace with enough resources for you to be able to test most applications, especially stateless ones. So let me take a look at what I already have on my namespace on Octito Cloud. I have nothing. Ksachit is my namespace. There's an interesting repo here in Octito or called Litmus on Octito. They're giving you a button which will help you to deploy all the Litmus infrastructure on your namespace on the Octito cloud. So I'm going to click this. So I can see the Octito cloud console has opened up, and it is installed all things that are necessary for running my chaos experiments. So it has deployed a sample app. It's a simple hello world app, right? It's just a web server that's saying hello. And it has put the Litmus operator, which we spoke about earlier, the cloud native operator. And it has also installed Litmus experiment for pod delete, the experiment CR, which has been pulled from the chaos hub. All this at a single click of a button. And this is your console to see your logs. The Helm chart is deployed automatically. It's available as a catalog. When you do deploy, and when you do deploy from Git or your Helm chart, when you do Helm chart, you have Litmus as one of the options there. So this has been automated here. It's already all installed. Let me go back to my namespace, and I can see that 2 replica deployment of Hello World is up and running, and I've got the Litmus operator running. It's the latest version of Litmus 1.7, which we released last week. And I have also got the chaos experiment CR for pod delete here. And I'll just give you a brief look at what this contains. I've done a -o YAML here, and you can see the definition of the experiment. It's going to run an image called Litmus Go Runner, which is going to do the chaos. It has got a set of environment variables which contain default values, telling you what's going to happen as part of the experiment. This is the duration for which I want to run. This is the interval I want to do pod deletes in. This is the nature of the deletes I want to do. And there are a few other options that you can check out in the docs, which I'm not going to. And it also, the Octito also puts, uses this permissions as part of its service account when doing chaos. So for pod delete, I need to be able to do chaos. And if I need to be able to do chaos, I need these permissions. There's also an admin mode in Litmus where you can give an all-encompassing service account with a lot of permissions to do chaos on all namespaces across different type of objects, etc. But we are also providing an RBAC that is specific to each experiment. So if you are in a multi-tenant environment as a developer and a lot of other people are also using your cluster, you want to restrict your chaos, or you want to restrict the service account doing the chaos to doing just that, not more. So that's what this describes, right? And this is the entry point, the experiment binary that's going to be executed. So this is there in the experiment CR that you picked from the hub. And on Octito, now I have everything ready, ready to do my chaos. And in order to do the chaos, we need to create the chaos engine, right? I have cloned the Litmus on Octito repo. That's why I'm showing you all these manifests here. We talked about the chaos engine that is connecting your application instance, which is Hello World app in chaos, in KSHIP namespace. It takes default KSHIP. And this is the kind of the app. And I'm going to basically run with an annotation check true. This means there might be several deployments sharing the same label, but I want to target only that app which has been annotated for chaos. And that's why annotation check is true. This way you can reduce the blast radius. And I'm also going to use a service account which has enough permissions to do this chaos. And I'm overriding some of the defaults of the experiment. I want to do just one replica kill. I want to do it for a period of 60 seconds, right? And I want to do it for 15 seconds where I just want to do 4. I think it's basically going to do a few iterations of chaos. That's what it is. So I'm going to apply this chaos engine, right? And after I do that, I'm also going to watch for what's going to happen on my cluster, on my namespace rather. You can see that a runner pod got created and a pod delete pod got created. These are the agents which are going to do your chaos. And the Hello World app is now undergoing kills. And in this process, you can see on Octito Cloud, they're giving me an ingress endpoint where I can actually see my app running. Let me go to that. Yeah, so this is the Hello World app, right? And I can always keep looking at this particular page and then keep doing my chaos here and then see whether this is available. It is in this case because we were running a multiple replica deployment. So you can say that hello world app with 2 replicas with the deployment spec that you pushed out is tolerant to single replica deletes done over 15 over 60-second period with every kill happening within 15 seconds. So this is the hypothesis. I just wanted to see if a single replica failure is tolerated. It can, and it is. My link is available. This way you can do complex experiments on Octito. You can do CPU hogs, you can do memory, you can simulate memory leaks, and you can do container kills in an ungraceful way. And you can also try to do disk fills and all these kind of things, right? So Octito gives you a very easy interface to deploy your application and also test it for chaos, right? And also give you the endpoints which can help you verify that your application is sustaining chaos. So take a look at this. If you are a cloud native developer, you can use Octito to develop your apps and also do the chaos. Very briefly, I'll show you what is meant by the development container and how you can develop in cluster. Right now, I am done with my chaos. And you can see the chaos result. I can just do a describe of a chaos result here to tell me what has happened. It basically says the experiment is passed and there's not much to push. But if it has failed, then you will also get the failure step, why it failed, and all the events on the chaos engine telling you at each stage what happened as part of the failure. You can see there are a lot of events that get generated at each phase. Your pre-checks, your post-checks, what is the summary, what action the operator is doing as part of your experiment and all that. Now, I have, as I told you, used the Octito repo. I've already cloned it. I'm going inside the application directory where I have something called Octito YAML. This manifest is telling me that it's going to simulate or it's going to swap the container of hello world deployment with this image. This image contains all the necessary tools for me to be able to build Golang or run Golang code. And it's also going to load all my application code. The main.go is going to be loaded into the development container when I do an Octito up. So you can see this when I do this, when I do the Octito up operation, it's actually going to create a development container for me. And what this means is in my namespace, I am now going to see not 2 replicas of hello world, but I'm going to see just one. It's actually starting to give it a few minutes. It's going to get converted into one hello world application. And what this hello world application is actually a Golang development container. And once I get into the Golang development container, I get a prompt to it here. You can see that I've got all the code, and then I've also got the deployment replaced. Now this has been swapped to use the Golang container. Let me make changes to my application, right? I'm going to just change the print statement. I'm just going to say hello from the chaos meetup or during the chaos meetup, right? I made this change. Now I'm going to run, and this change, whatever I just made, is actually going to be reflected in the development container. You can see this, and this is already running on the cluster. This is nothing but this particular pod. Now I can go ahead and say go run main.go, and it's actually going to show me the new image. It's basically going to show me the new hello string. This is what you had earlier. Now you're going to have during chaos meetup, right? So this is how you can do in-cluster development. And now, once I'm confident with this code, I can do an Octito push to push the image, and I can go ahead and do my chaos experiments to see if it survives chaos. So this is what it is. And this is how Octito is enabled us. They've become an adopter of Litmus, and they're also part of our SIG integrations team. SIG integrations means basically a special interest group in Litmus, which talks about integrations of other tools with Litmus. There are other such special interest groups which we are talking about, we are discussing on Slack, so please join there to find out more. Now, probably stop sharing, take questions if there are any, and then probably pass it over to Shubham for the probes demo.
Yes, I'm Pandiraja here. Okay, from Chennai.
Hey, Pandya. Hi.
Yeah, yeah. Actually, can you just explain how it is works? Because you are not building the container, you are running, I mean, pushing that image. How it is internally works, how your chaos container builds that image. I mean, copies your code, takes your code, and builds in container. Sorry, in
Yeah.
GitHub.
So yeah, so the part where they were showed, I did not build an image, but changes are reflected on the dev container, right? That's what you're asking, Pandya. So this is about, there is a protocol called syncing, which Octato have been using underneath. So what they do is they create a persistent volume, which hosts all your information, basically loads everything that's there on your workspace and makes it available on the cluster. And they use the same thing to keep the persistent volumes content updated, and thereby whatever changes you make on your workspace is automatically reflected on the development container on the cluster. And they give you the container with the image that I showed you was Octato Golang. It's the base image that they are providing us, which has the basic tool set to run Go. They also provide such scaffolding for Node.js and Python and other tools. So you can run all the basic commands. If you want, you can build in Vim into it, or you can build any other debuggers if you want into it. But typically you might not need to. You can just use your VS Code or any other IDE. I just used Vim to go edit it. You can use your own IDE. They're going to ensure that that gets reflected on your PVC on your cluster. And that way they are going to load your code into the container and then help you just run your commands and see what is happening. And the image that I showed is a pretty simple one. Whereas, let me just share the screen to see how we are using it in Litmus. So in Litmus, each experiment has its own requirements. It's a different experiment need different service permissions to run, service account permissions to run. Some of them even need Docker socket files mounted from your nodes, right? So those things we are already putting out in our Litmus experiment. There's a dummy deployment that we use in each experiment, right? I'm just going into the experiments folder of the Litmus Go, which is the source for the experiments. You can see some of the experiments like maybe network loss or network latency. If you see this test YAML here, you can see it's actually having a specific set of environment variables. So this is a dummy application using BusyBox. I put this deployment, and then I swap it with the Golang image provided by Octato. I have all the things necessary to run my experiment inside, and I just go to a go run of the experiment binary. So that's how we use it. And does that answer your question?
Yeah, yes, yes. Yeah, I have one more question also. So I'm using stateful sets. Okay, so my data will be, I mean, I'm using the host path volume only to store my data, the container data. Okay, so I'm testing too many times, so it is keep on creating new volume again and again. Volume means new tree, and it is storing the data again and again. So, is there any way to clear using this stairs? Clear my, I mean, data. I mean, test data from.
Yeah, I think Octato right now is not providing that capability yet. It works with deployments, not so much with stateful sets yet. Having said that, I think there is an Octato enterprise where I think you need not just use it on cloud in a namespace option here. You can use it on your own clusters where you have your full configuration. I think that support should be there in that mode. I'll probably try and find out and get back to you on that, Pandya. I think that support is not there in the cloud yet.
If you mean the clearing test data, which is created during this test deployment. Uh,
If it's a deployment and you're using some volume and it's basically test data, then you can actually always go ahead and do a destroy and recreate. And it does a redeploy of the whole stack with the basic manifest model you have on Git or Helm. So it's a fresh thing that sort of comes up. You could do that if that's what you're asking. For example, now I could do a destroy, and it's going to remove all the manifests, the operator, and the hello world, everything that I created, and then I can go ahead and do it once again. It will be a fresh setup.
Okay,
And
so are you
mount your host paths again.
Okay, you are using host path? Are you using a host path?
I'm not in this example, but I think you should be able to do that.
Okay, okay.
Yeah, but having said that, I think Octito has several modes, like I mentioned, the cloud, the enterprise mode, etc. There might be some restrictions on what you could do on the cloud versus what you could do on the enterprise one with your own clusters. So I'm also not really completely aware of those feature set, which we could already we could always take a look at the Octito documentation for that. I think they have a very good documentation, and they also have a good Slack channel on Kubernetes workspace, just like Litmus. So you could always find out more from there. Right now, the experiments themselves are not stateful. So we are able to do it with Octito Cloud without having to do that.
Okay. Yeah, thank you. Thank you, Karthik.
Yeah, thanks. Okay. Yeah, if there are no more questions, I think Shubham, you can go ahead.
Okay, thanks, Karthik. Hi, I am Shubham Chaudhary, one of the contributor of LitmusChaos. So before going to demo, I just want to describe why we need probes. So, I mean, our chaos experiment contains some default checks in the pre and post chaos sections. For example, our generic experiment contain checking for the status of the application under S and the auxiliary applications. And for example, Cassandra is checking for the distribution of load over the ring along with the application status check. And our Kafka is checking for the message stream along with the Kafka setup, cluster status check and all these things. So we have some default checks. But if user wants his custom checks, so if he wants some custom check, he can use probe there. So in probe, he can define his custom check. He can define the probes in the chaos engine and he can use them. So let me explain how we can define chaos engine. So as of now, we have three type of probes. So one probe is HTTP probe. So in HTTP probe, we can define inputs as URL and expected response code. So, and one is the mode. So mode can be of four type: SOTs, start of test, EOTs, end of test. Age can contain both SOT and EOT, and one is continuous. So and running property contain this probe timeout. This is the interval. This is just the polling interval and the retry. And another one is a CMD probe. So in the CMD probe, it was of two type. One can be used as a inline, or one can use a image. So if you can define this value using source. So if you need some extra dependency which is not in our Go runner image, so you can define your image inside source and you can run your put your command here, so it will run inside that image and check and match for the expected result. You can place the result here, and the same run property is defined here in the inline. So you can define your kubectl other commands. You can run any command which can be run using which can run directly inside our container, which can use the Go runner image directly. So this is the KTS probe. So in KTS probe, we can define it is for the Kubernetes native resources. We can define our GVR value, group version resource value, namespace, and field selector. Then it will check for those resources. So so using mode, we can define it will run in SOT, EOT, or as both. So for the sample example, I have put my values. You can put your values accordingly. So I put some as SOT, some of SOT, EOT, and some as age. So yeah, I will run this. So I have already installed Litmus and all things are already running. So I just apply my engine. So my engine is created. Let's wait for the runner pod. Yeah, our chaos pod is created. I mean, we can check the logs here. So we are printing the log, probes details here. I mean, the probe type, I mean, pre-chaos and post-chaos and status and name and all these things, and pass and fail as well. So in log, we can verify, and we also creating events in chaos engine for all things. So here also we are checking for EOTs running and probe is successful or unsuccessful accordingly. Yeah, here I'm using pod delete as a example. I mean, I define the probe for the pod delete, so it is running pod delete experiment. So you can verify nginx is 21 second ago. So our experiment is completed. We can check the events in chaos engine. Yeah, we have all the events. So it is passing, probes is passing both AUT and EUT sections. And summary event is also this passed. So we can also verify the probe status in the result. Here. So this is the probe status percentage. So on the basis of how many probes run, this result will be calculated. So our all the probe weightage is same as, I mean, the probability is same. So this is just the pass probe divided by total probes. And here is the probe detail, I mean, name and type, and on the basis of it is SOT, EOT or both. So post and this, and we can check passed or failed here. And some event is there, like we can check.
Just to pitch in what Shubham has been showing, I think one of the things we discussed early on in this call was the hypothesis, right? What you want to check as part of your experiment. So you might have a lot of checks that you depend upon on a day-to-day basis. You might have some metrics that your exporter is exposing to tell your app is healthy, or there might be some services that you expect to get created or removed as part of your experiment. So all these things need to be built into the experiment, and we need to enable it to be done in a declarative way. Just before we introduced these probes, this was possible, but you had to rebuild the experiment. You had to create your own experiment, build the image, and create an experiment CR to do that. But now, most of your hypothesis can be covered via different probes that you can declaratively assign within the chaos engine. I think that's really the key here. Go ahead, Shubham.
Yeah. So I mean, this is the only example. I think any questions?
Hi, Subham. It's Orko. The different probes, as I understand, are used to measure the resilience of a system and define our needs for resilience, right?
Yeah.
So what if one of them is more important to me than the other? Can I set different weightage for them or something like that?
Okay. So as of now, I mean, all the weightage of all the probe is same, but we can have this weightage thing as well.
Okay.
Yeah.
Great feedback, Orko. That's a good one. Weightage and criticality of the probes is something that we are definitely interested in.
Thanks, Shubham. Thanks for giving a great demo on the Litmus probes. So before we conclude, I would just like to say that we are available on a Slack channel again. Once again, feel free to join in. You can post in any questions if you want. Right now, we are available for a couple of minutes more. And those who want to get started with Litmus tutorials are available on YouTube. So you can just check out Litmus tutorials, which will help you get started with your journey. And the docs are always available. So we can conclude. If anyone has any questions, we can answer them and then we can end this call.
Yeah, hi. I just started on Chaos with using Litmus. So one of the questions I had was when I run the pod delete experiment, it says passed. So what does it mean passed? My pod, whether it is applicable or not, it has redness and liveness probes, right? When the pod is, when the redness and liveness pass, then my pod is available. So when it says the pod delete experiment passed, did it check the liveness and redness probe, or what did it? How did it conclude it passed?
Yeah. So the category of experiments called generic, Randir, that you might have pulled from the hub. So these experiments by nature have very, very minimal checks to qualify a service as being done. If you're using liveness and readiness probes, that would mean that your deployment is up and running, the pod phase will be running, and your container statuses will be alive, they will be running. Because something being native probes, those will actually kill your deployment if the health conditions are not met. So if you've already followed the best practice of using liveness and readiness probes, it means that checking for your pod and app pod and container status is indicative of health of the app. So we do that in a couple of places. We do that before and after doing the chaos, right? And if the steady state check is before chaos and your post chaos check is the one after. And then if it is running, we say that the experiment has passed. But the generic experiments are really vanilla experiments. They are mostly onboarding kind, right? We are introducing these probes that Shubham just demonstrated to help you add more conditions. So if you are saying that the app that you're killing is really a central piece, and there are some downstream application depending upon this app, and your health can be verified only upon the checking the success or the health of those downstream apps, or if you are having your application expose certain metrics to identify its operating, its optimal operation. For example, if there is a minimum amount of latency that your service is working with, and that's getting recorded somewhere, and you want the Litmus experiment to check that before we say pass, that can be done via these probes. That is what we have introduced newly. For now, the experiment as it is in generic, the plain experiment and the chaos engine examples on the docs will set it to pass if your app is alive. And implicitly, it checks the liveness probe because liveness probe is going to ensure a deployment is up in the first place.
Yeah, thanks. So, and the results, chaos results, is there a way to export the results to a place where I can see them on UI, or I need to just say kubectl get chaos result?
Yeah, so these chaos results are being exported as metrics by the chaos exporter in Litmus. And there is also the event exporter, which we are using, which is basically a fork of the Heptio event router. We are using it as an optional deployment in Litmus today. What it does is each event that's getting generated in your chaos engine is actually going to, each event is going to get converted into a Prometheus metric, and you could instrument your existing application dashboards to overlay these chaos events or chaos metrics to sort of get a picture. Let me just explain very briefly what I'm trying to show. Just give me a moment.
Yeah, that's very interesting. I want to see the events being exported to Grafana or Elasticsearch to see them separately from this.
Sure, just give me a moment. I'll be able to show that to you. Just pulling up the links for the same. Meanwhile, as I pull them up, are there any other questions from anyone?
Just to add on, Karthik, Randeep, stay tuned. By the next release, September 15th, we will have a alpha version of Litmus portal that will be a UI-based things. You will be able to see analytics and other things from the dashboard itself. So you will have a history. The first version may not have the export feature, but you should be able to get it over the UI.
Okay.
Yeah, let me just share my screen now. I think I've managed to put that up. So let's say you have, I'm using the Sock Shop application. It's a microservices demo application from Weaveworks. And there are a lot of microservices within it. And this is a Grafana dashboard that that's capturing some of that information. Orders, catalog, payment, these are all microservices with their respective metrics like queries per second and latency. And we are also trying to export the chaos events and as metrics. And from the same data source that's pulling the Sock Shop metrics, we're also pulling the chaos metrics. And I can sort of annotate my panels, Grafana panels, with the chaos details. So you can see each of these, for example, if I try to highlight this, is basically telling you that the latency just spiked from what it was, from maybe 10 seconds or an average of, let's say, 2.5 milliseconds to around nearly 20 milliseconds when I did the chaos for a CPU hog test. I am just trying to hog some CPU on the node on the pod for a temporary period of time. And I can see that for this period, the chaos is active and the latency sort of just went and then came back and then it's sort of fluctuating. So this is something that you can do with the events that you see here. So for example, I just will show you, I think I've removed the chaos engines. I might have them.
This is exactly what I was looking. So is this experiment dashboard and the chaos experiment YAML, all these are available somewhere so that I can refer to?
Sure. Yeah. So this was the events that I was mentioning, which you can sort of use to annotate Grafana apps. The dashboard itself, we're trying to, as part of each release, we're trying to push out some standard dashboards, chaos instrumented dashboards. We now have one for Sock Shop. It's there here, and there's a demo folder inside Litmus, Sock Shop application, and there's a deploy monitoring, and has a dashboard, which has all the chaos queries inside it. You could always use that to do your own visualization. We will be putting out some references into this folder.
Yeah, thanks a lot. This is helpful.
Cool. Thanks, Randeep. And yeah, thanks for your feedback on the air-gapped, both the non-root containers. I think they are available now. And we're also trying to add some documentation. We reduced the number of images that you have to build downstream for, you had all these helper pods, etc. earlier. Now this is all embedded into Litmus Go Runner. So there are these three images: operator, runner, and Go Runner.
Just one more feedback, if you the container delete, right? It is looking for Docker container. So our container runtime is container D. So in Kubernetes there is no Docker. We don't install Docker. It comes with container D. So when I do the container experiment, it fails because it's trying to connect to Docker server. Docker daemon.
Right. So we introduced the support for the container D in a few releases back. So in the experiment docs, you can use the container runtime value. You can use it for, you can give a container path. So sometimes for cryo and other things, especially in the gravitational and other clusters, the socket file is in a different place. So you can provide that by a container path. And the lib can be Pumbaa for Docker and Litmus for container D. So you can provide this for container D or cryo, and you can use the same Go Runner image there. So in the engine example that we've put out here doesn't have this, but you can provide the lib image if necessary. If you are using your downstream image instead of the standard LitmusChaos Go Runner image, it looks like this. I can show you on the experiment. So this is generic container kill, and this is the experiment CR. And in this experiment CR, we are providing this lib image, which defaults to this. If you're building your own Go Runner, you can provide that here for Go Runner, and provide your container path, and lib will be Litmus instead of Pumbaa. So for Litmus for these two. So that should work for container kill. And we are, the network chaos is actually is something that we're adding for container and cryo in 1.8. We have a community member who is contributing the tests for container support for network chaos. Network chaos actually looks for Docker today. Like you mentioned, the problem for container kill, the network chaos looks for Docker today, and support for container on those experiments is coming in next month. So you should be able to do that as well.
Yeah, thanks a lot. This is very helpful.
Thanks, Randir. Thanks a lot. Do we have any other questions or any feedback?
No, I'm good. I'll share my feedback on Slack as I progress.
Sure, Randir, sure. It's great.
Sure. And if you have just a common request, do take a look at the repos, and please create issues and PRs wherever you feel necessary. There are special interest groups within Litmus where we are talking about certain aspects of the project. You might be interested in running experiments in CI/CD. You might be interested in the observability or the monitoring, and you might be interested in maybe other aspects like how you can add more experiments, new experiments, etc. So there are special interest groups. You can take a look at that. If you are interested, please reach out to us on Slack. We can add you. There are membership tracker issues also, so please raise a comment there if you want. There are GitHub teams that are meeting where we will add you into a GitHub team and probably meet once in a month, apart from the community sync-up call, where we will try to add your requests into the release priority. So please take a look at that. If you are using Litmus in some capacity, feel free to add yourself as adopters into Litmus, so that helps us sort of further the momentum that we already are getting around Litmus. So the community participation is a completely community-driven project. So your acknowledgement of usage of Litmus is also of great value to the community. So please take a look at that. Yeah. That's all we have.
That's it, guys. Thanks a lot. Thanks a lot for joining us on a weekend. We really appreciate your presence, and we hope that we fulfilled your journey with, we started off your journey with Cloud Native Chaos, or we fulfilled your Saturday. Looking forward to see you all next time, next month, same at the same time, the third Saturday of the month. Feel free to check us out. Thanks, everyone. It was a great session. Thank you.
Okay. Thanks, everyone. Have a great weekend. Bye.
Thank you.